SAMSO, the Space and Missile Systems Organization, a United States Air Force element of the Air Force Systems Command. Headquarters, Los Angeles Air Force Station, El Segundo, California. Mission: planning, developing, and acquiring superior intercontinental ballistic missiles and military space systems essential to the national defense. Resources, people, and facilities. Involvement, total, from drawing pad to launch pad, from idea to product delivery. SAMSO manages military space programs, spacecraft development, their launch vehicles, ground equipment and launch equipment, and operates the tracking stations to command and control these space travelers. In performing these national defense tasks, SAMSO is assisted by Aerospace Corporation, a not-for-profit organization which supports SAMSO in planning, in general systems engineering, and technical direction on selected high-priority programs. Since the inception of its parent organization in 1954, SAMSO has managed the development of Atlas, Thor, Titan I ballistic missiles, and Titan II. Early Minuteman Is have completed their strategic deterrent job and have stepped aside for Minuteman II and III, Alert and Prime. Titan II, Minuteman II, and Minuteman III stand ready in the Strategic Air Command operational inventory. SAMSO's headquarters, military space activities, and advanced ballistic reentry vehicle programs are located at Los Angeles Air Force Station. Its ballistic missile systems experts of the Minuteman Systems Program Office are located 80 miles east at Norton Air Force Base. Winner of many awards for outstanding management, the Minuteman office is its own system integrating contractor, accomplishing this task with the assistance of TRW for systems engineering and technical direction. SAMSO's Space and Missile Test Center, SAMTech, is located at Vandenberg Air Force Base, some 50 miles northwest of Santa Barbara, California. There, SAMTech's 6595th Aerospace Test Wing launches space vehicles and research and development flight tests of ballistic missiles along the Western Test Range. Operated by SAMTech for the Department of Defense, this range extends across the Pacific to Eniwetok and Kwajalein and south to the Phoenix Islands. The Strategic Air Command performs operational readiness test launches of ballistic missiles from Vandenberg. On the East Coast, SAMTech's 6555th Aerospace Test Group at Cape Kennedy, Florida, performs similar space launches from the Department of Defense Eastern Test Range. The Air Force Satellite Control Facility headquarters, which is located within the SAMSO complex at Los Angeles Air Force Station, directs the operation of the Satellite Control Facility, including the Satellite Test Center at Sunnyvale, California, 7 remote tracking stations located around the world, and a test group at Hickam Air Force Base, Hawaii. The operational hub of the Air Force Satellite Control Facility is the Satellite Test Center at Sunnyvale, California. The Air Force Satellite Control Facility is also responsible for satellite control operations. This Department of Defense space range provides the Air Force the means to command and control orbiting military satellites. Depending on the space mission, the Satellite Test Center tracks, instructs, queries, and receives information, performing these operations on the many spacecraft in orbit. The remote tracking stations are tied together electronically with the Satellite Test Center at Sunnyvale. SAMSO's most important resource is people. People with the skill and know-how to give a concept life and put it to work. There are 5,700 people in the Space and Missile Systems Organization. military and civilian, nearly equally divided between headquarters and its U.S. and worldwide locations. Selected for their specialized experience and educational qualifications, they are well trained to perform their tasks. SAMSO, during an average fiscal year, directs nearly $2 billion worth of space and ballistic missile contracts with private corporations who have proven their development and production know-how. This skilled military science industry team has produced and deployed several ICBM systems for the Strategic Air Command. The rapid responding Titan II can be launched singly or in salvo from within its hardened and dispersed silos near Davis-Monthan Air Force Base, Arizona, McConnell Air Force Base, Kansas, and Little Rock Air Force Base, Arkansas. Complementing the massive wallop of Titan II are 1,000 Minuteman missiles deployed over large areas near Malmstrom Air Force Base, Montana, Warren Air Force Base, Wyoming, Whiteman Air Force Base, Missouri, Ellsworth Air Force Base, South Dakota, and Minot and Grand Forks Air Force Bases in North Dakota. Minuteman, the first operational solid propellant ICBM in the United States, can be stored with little maintenance for long periods in underground silos. 10 Minuteman launchers are controlled from one underground launch control center. The concept of missile sites not constantly manned releases personnel from other duties and permits operational and maintenance tasks to be performed by a relatively small unit. Minuteman can be in the air within seconds after receipt of launch command. Minuteman III, with improved accuracy, greater range, and capability to carry multiple warheads and penetration aids, is replacing earlier Minuteman as a primary strategic deterrent for national defense. SAMSO is constantly examining ICBM alternatives to give our strategic retaliatory force continued effectiveness against potential technological advances in the decade to come. SAMSO's ICBM field teams, officially designated Site Alteration Task Forces, nicknamed SATAFs, bear responsibility for all construction, emplacement, and continuing force modernization of Strategic Air Command ICBM sites. As existing missile sites are being improved, Minuteman program personnel are conducting extensive studies to identify alternate means of ensuring that the strategic missile force can survive against any enemy attack. New types of protection and deception are constantly being tested and evaluated against the potential threat. SAMSO manages a tri-service Department of Defense program called ABRES, an acronym for Advanced Ballistic Reentry Systems. This program develops new concepts and technologies for future ballistic reentry systems needed by the Army, Navy, and Air Force. The ABRES program takes into account all problems associated with proving advanced reentry technology. New reentry vehicle configurations, new structural and heat shield materials, new components and mounting techniques. Since defensive systems advance with ballistic weapon development, methods are undertaken to confuse missile defense systems. ABRES develops and tests decoys and chaff systems, among other countermeasure and penetration aid techniques. Testing this hardware would be much more time-consuming than it actually is, were it not for the Athena program. Athena allows scaled reentry models to be tested. The Athena test program reduces the necessity for complex multi-payload test flights by pre-testing reentry vehicle configurations, structural materials, decoys, electronic countermeasure systems, antennas, fusing and arming devices, and heat shield materials. Test payloads are launched by the multi-stage solid propellant Athena booster over a 420 nautical mile inland test range from Green River, Utah to White Sands, New Mexico. As the re-entry vehicle enters the heavily instrumented White Sands range, the final propulsion stage is fired to drive it through the atmosphere at ICBM re-entry velocities to simulate full-scale deceleration and thermal conditions. The most promising re-entry vehicle designs or components are then full-scale tested to ICBM ranges and conditions aboard surplus Atlas or Minuteman boosters from Vandenberg Air Force Base down the Western Test Range. SAMSO contributes significantly to the nation's ballistic missile defense program by firing test re-entry vehicles from Vandenberg toward Kwajalein, where they serve as targets for the United States Army Spartan and Sprint interceptor missiles in support of the Safeguard program. Air Force in space begins with launch vehicles, space boosters from SAMSO's Military Science Industry Team. Scout, a four-stage vehicle originated by the National Aeronautics and Space Administration, employs solid propellant motors. Scout can place a 350-pound payload into orbit 100 nautical miles above the Earth. Thor is a family of boosters. With a burner 2A upper stage, Thor can place 700 pounds of payload into low Earth orbit. Strapping 3 solid boosters to the Thor skirt section created the thrust-augmented Thor, which, with an Agena second stage, gives sufficient muscle to orbit 1,700 pounds around the world 100 miles above its surface. Increasing the booster length introduced the long tank thrust-augmented Thor with the Agena upper stage and the power to place 2,750 pounds into low polar orbit. Where greater power is needed, Atlas SLV-3A with an Agena can put 7,600 pounds into low polar orbit and 1,800 pounds to escape velocity, boosting the Rangers to the Moon or Mariner to Mars and beyond. The Agena space vehicle is a sophisticated upper stage with multiple burn and attitude orientation capabilities. Atlas SLV-3C and a NASA Centaur upper stage produces the greatest Atlas payload potential. 9,000 pounds into a low altitude orbit, 2,800 pounds to a soft landing on the Moon. The Titan 3C space booster starts with the Titan II core and adds 2 10-foot diameter solid boosters that generate nearly 2.5 million pounds of thrust. It adds the versatile trans stage, a payload carrying upper stage that can be started, stopped, and steered. Translated to payload capability, this means 22,500 pounds in a 100 nautical mile orbit, 6,800 pounds to escape velocity, or 3,400 pounds to synchronous equatorial orbit. Titan III is also used in other configurations. Titan 3D eliminates the trans stage. Titan 3B omits the solid rocket boosters and uses an Agena orbiting vehicle in place of the trans stage. Planned for the future is a Titan 3E for NASA, which will use the Centaur upper stage, further increasing the payload capability of this versatile system. SAMSO's standard launch vehicles: Scout, Thor, Atlas, and Titan III have successfully completed over 80% of all United States space launches with a high degree of reliability. Spacecraft, boosters, ballistic missiles, and satellite control share working space and time with other vitally important programs. Examples of these include unmanned space systems such as nuclear detection satellites and communications satellites. The highly successful Vela satellite system detects nuclear detonations in space and the Earth's atmosphere. Provided with Atomic Energy Commission detection equipment, 6 pairs of Vela satellites have been launched into orbit 60,000 miles above the Earth. Each satellite is spaced 180 degrees opposed from its twin to provide optimum coverage. In addition to the primary mission, the Vela system collects several kinds of scientific research information, such as solar and cosmic radiation. Communication systems are of vital concern to the Department of Defense. Worldwide requirements, both strategic and tactical, have brought about military satellite systems to satisfy the Defense Department's need for instantaneous global communications. Between 1966 and 1968, 26 initial Defense Satellite Communication System spacecraft, each weighing 100 pounds, were placed in a subsynchronous orbit, 18,300 nautical miles above the Earth. They answer a vital need for linking large stationary ground communication centers into a worldwide net. But tactical communications on a worldwide scale cannot depend on stationary ground stations. Commanders must talk with scouts, ships at sea, and in-flight aircraft. Communication between tactical units in the field via satellite was proved feasible during the first phase of the tactical satellite program. 2 Lincoln experimental satellites, LES-5, launched in 1967, and LES-6, orbited a year later, pointed the way to a full-scale satellite, TACSAT-1, the largest and most versatile communication satellite ever built. 27 feet tall and weighing 1,600 pounds, TACSAT-1 repeats communications on UHF or microwave, or both simultaneously. Currently, TACSAT-1 is in synchronous orbit 19,300 nautical miles above the eastern Pacific. A satellite system based on TACSAT-1 and LES-6 provides initial operational capability for military commanders to exercise immediate command and control of their tactical forces. In late 1971, a program for launching a new series of satellites was begun for the Defense Communications Agency to replace the aging initial Defense Satellite Communications System. The satellites for the new Defense Satellite Communications System, Phase 2, are launched in pairs by Titan 3C boosters. With their greater flexibility and increased power and message handling capabilities, these Earth-pointing satellites provide communications covering either large or small areas of the Earth's surface as desired by the Defense Communications Agency. SAMSO is also participating in the development and acquisition of the Navy Fleet Satellite Communication System, which will be used for fleet command and control and tactical links for high-priority Air Force and Department of Defense communication use. As part of an international cooperation program, SAMSO has developed and launched communication satellites for the United Kingdom and for the North Atlantic Treaty Organization. These long-life stabilized satellites were launched into Earth-synchronous orbits using NASA Thor Delta boosters. Their antennas always point toward the Earth. The United Kingdom satellite allows communications across the Mediterranean and Indian Oceans. The NATO satellites allow communication among member nations of the North Atlantic Alliance. SAMSO is continuing to cooperate with the United Kingdom and NATO in providing advanced communications satellites to satisfy more complex and sophisticated operational needs. The essence of SAMSO's progress is development of the technologies and future systems that can serve the space and missile requirements of the nation today and in the years ahead. SAMSO technology looks to the future, predicting problems that will be encountered and devising solutions, all the while being guided by the many variables introduced by our nation's changing needs. One example, system and component survivability. Our space and missile systems must survive in hostile environments, nuclear and non-nuclear. As an illustration, overpressure or shock from a nuclear weapon burst on or near a missile launch site. A method to examine the solution is the high explosive simulation technique, abbreviated HEST. The results have provided much valuable data on actual Minuteman launch complex structural survivability. The techniques of HEST have been adapted to other elements of the survivability program. Similarly, study and test of techniques to assist survival of space systems is also underway. All Air Force laboratories support SAMSO by research and development work related to SAMSO's technology needs for the future. The same kind of technology support is also provided by laboratories operated by other Department of Defense organizations, government agencies, industry, and universities. Many technology demonstrations can be accomplished under simulated flight conditions within a laboratory. However, space technology proofing must eventually be demonstrated in actual space environments. Here, the DoD Space Test Program appears. Yet another example of SAMSO's overall technical responsibility. Any member of the Defense Department community may apply to the Space Test Program for launch support to place approved experiments in a space environment. SAMSO provides space vehicle integration, engineering, and launch services for several launches each year, carrying as many as a dozen different experiments in a single payload. SAMSO looks to the future, not only within the broad spectrum of technological disciplines, but also directs much effort toward development planning of future space and missile systems. Plans have been developed for a precision navigation satellite system by which high-speed aircraft, ships at sea, and ground forces can establish their exact position. SAMSO is assisting the National Aeronautics and Space Administration in planning the Space Transportation System. This system will provide a national space capability which promises versatility and flexibility and ensures less expensive space launches. SAMSO's role in this endeavor is to assist NASA in space shuttle evaluations and to identify Department of Defense requirements in payload, weight, size, and potential methods of operation. All our development planning programs are in a state of constant flux and may or may not materialize as concrete programs. They all depend on our nation's need. The development planner assists in guiding and directing technology. His concern is with national policy, threat assessment, military necessity, mission accomplishment, optimum approach, alternatives, adaptability of forecast, and technological advances. To develop space and missile systems requires 5 to 10 years lead time. In that time period, many factors, technological, political, economic, may compel dramatic shifts of emphasis. Development planning, therefore, with accompanying engineering and technological efforts, is continually undergoing change. Future space and missile systems will benefit from SAMSO's careful systems planning. Advanced ICBM systems, space defense systems, more efficient space power sources, all these come within the domain of SAMSO's development planners. Cost will be held to a minimum. Performance of ground, propulsion, guidance, and re-entry systems will be continually upgraded. SAMSO balances this advanced planning with a hard eye toward cost factors. To achieve lower costs in all these efforts, SAMSO works closely with other units of the Air Force Systems Command. The SAMSO story has covered ballistic missiles, space launch vehicles, advanced re-entry systems, unmanned satellites, advanced technology, and planning for future systems. These have been only the chapter headings of the SAMSO story. The details are found in working with the many programs and projects. The United States Air Force Space and Missile Systems Organization is people working within technological disciplines in response to current and projected needs of our nation's defense. It is the challenge of the future to develop systems which will enable the United States to attain, maintain, and sustain superiority in space and ballistic missile systems.